I'm not exactly sure what's going on. Hold on one second. Okay, so we're going to talk about the Pythagorean theorem. And the Pythagorean theorem is a theorem that you should automatically think of whenever you're given a right triangle. And remember, when you're given a right triangle, you will see a little box in one of the corners. Okay, so this is a right triangle, and what we know are the two sides that that form that 90-degree angle are going to be called the legs of our triangle, and C is the hypotenuse of our triangle. Okay, so A and B are the legs of our triangle. They form that 90-degree angle, and C is our hypotenuse. It's always across from the 90-degree angle. Okay, so this equation, a squared plus b squared equals c squared, becomes really important when we're looking for side lengths of triangles. If we look at this first one, we've got a triangle, and we know that this is where a 90-degree angle is, and this is the square root of 26 centimeters, and this side here is 11 centimeters. And what we're looking for is this side over here, the hypotenuse. So we know that A and B are the legs of the triangles, so A and B are going to be 11 and the square root of 26. Now it doesn't matter which one you place first, because we're simply adding, and we know we can add in any order using that wonderful commutative property. So honestly, it doesn't matter which way or what you substitute in for A and what you substitute in for B. What we do know is that C will always be that largest side, right? C has to be that biggest side. So if I substitute this in, I've got the square root of 26 squared plus 11 squared equals x squared. And that's using the Pythagorean theorem, a squared plus b squared equals c squared. Okay, now the square root of 26 squared is simply 26. And that's because if we have the square root of 26 squared, we have the square root of 26 times the square root of 26. And if we have 26 times 26 under the radical, we know that this is a pair, and one will come out. So by definition, if you have the square root of something squared, whatever's underneath the radical will be the solution for that, or will be the simplified form. So we've got 26 plus 11 squared is 121, and that equals x squared. 26 plus 121 is 147, which equals x squared. And now to solve for x, we need to take the square root of each side. The square root of x squared is simply x, and the square root of 147, well, that can be simplified. So we want to go over here and say 147. We know this is a composite number, and I know that it's divisible by 3 because of some property rules, which this one, when things are divisible by 3, if you add up the numbers and that number is divisible by 3, then the entire number is divisible by 3. So what I just said is if we add up 1 plus 4 plus 7, so we add up these digits, we get 12. And since 12 is divisible by 3, 147 will also be divisible by 3. Okay, so that's called a divisibility rule. So 147 can be factored as 3 and 49. 3 times 49 is 147. Well, 49 can be factored to 7 and 7. So the square root of 147 is the same as 7 times 3. Okay, well, we've got a pair of 7s, and so since we have that pair of 7s, 1 7 comes outside, and what's left is the square root of 3. And since we're dealing with centimeters, x is a distance, we have 7 times the square root of 3 centimeters equals x, or we can write it x equals 7 times the square root of 3 centimeters. And I want it in radical form, not decimal form. Okay, let's look at one more problem. What if we're not looking for, well, you have to know what you're looking for. So if we look at a problem and it's given us the 90-degree angle here, and we're told this side here is 6 yards, and this side over here is 101 yards. Okay, well, it might be a good idea for you to go ahead and just write down what each side is. Okay, and we know that these are the legs, so we can call this A and this B, and this over here is the hypotenuse, so we know that that's going to be C. And it might be a great idea for you to do that when you're given a picture or a figure, so that you know exactly what you have and what you're looking for. Okay, so what we have here is we have a leg and we have a hypotenuse, and what we need is the other leg. Okay, so if I'm using my equation that says a squared plus b squared equals c squared, that Pythagorean theorem, I'm going to substitute what I have, which is 6 squared plus x squared, and that equals the square root of 101 squared. Now 6 squared is 36, and the square root of 101 squared is 101. So now I'm going to subtract 36 from each side, and when I do that, I have x squared is equal to 65. And then I would take the square root of each side, because I need just a simple x. So the square root of x squared is x, and the square root of 65. Well, 65 can be broken down to 13 and 5. And since neither of these are the same, we don't have a matching pair underneath the radical of factors, nothing can be simplified. So we simply have x equals the square root of 65. And that would be my final answer. Now, whenever you have a right triangle, this, like using the Pythagorean theorem, should come to mind. Like, that's a great thing to do. Okay? A great resource, a great equation, something that should just pop in. I can solve for sides. If I know 2 of them, I can find that third simply because of the Pythagorean theorem. Okay. Thank you very much, guys.